So let's talk about factoring polynomials. In particular, we really want to focus on factoring quadratic equations. So I have here a quadratic equation drawn here, and this is the equation x squared plus 10x plus 25. So let me redo this. When we have x squared plus 10x plus 25, and we're going to factor an equation, what we need to do is we need to figure out what two terms. Now all equations are not factorable by real numbers. They're all factorable, but not necessarily by real numbers. We're really only concerned with real numbers here. But since this is a second degree equation, it means we're going to have two factors. So that's why I put two blocks of parentheses here. And let's first look at the first term in this quadratic equation, this second degree polynomial. And we see that it's an x squared term, which means that we're going to need to have an x here and an x here, because our first operation is this term times that term, which gives us an x squared. Okay, so now let's focus on this constant here. That's why I have 25 written over here. 25 has actual factors of 1 times 25. That's one set of factors, but it also has 5 times 5. Okay? So I can have as my second number here either a 1 and a 25, which would mean that when I did this and I multiplied 1 times 25, I'd get 25. That looks good. Or I could have 5 and 5. Well, how do we decide which factors to stick in here to make this thing work? So far we've got these first two terms working. Now we've got to figure out how to get this middle term. Well, it's the way the middle term works out. If we go back and we look at the polynomial back here, the way the middle term works out is this second term times the first term, and the first term times the last term produce both x terms. In this case, we had 12x minus 3x equals 9x. So thinking along those lines, with a equation like this where we don't have any coefficient in front of the x squared, we can see then that the two factors for our 25 must add together to create 10x. Well, if I take 1 plus 25, I get 26. That's not 10. But if I take 5 plus 5, I get 10. So that will actually work for us then. So we decide to choose the factors 5 for 25, 5 and 5 here, because we see that 5 plus 5 equals 10. Now, we have to decide on a sign. If we make this negative, then here we got negative 5 times negative 5 equals positive 25. X times x equals x squared, so the first and the last term are the same. But we'll see that when we do this, the purple lines here, this times this, and this times this, we're going to get minus 5x and minus 5x, and we add minus 5x to minus 5x, we get minus 10x, and this is positive 10x. So clearly, this needs to be a positive sign here. And now that produces the correct values. So we've got x times x is x squared, x times 5 is 5x, we got 5 times x is 5x, and 5 times 5 is 25. And just to check things, it's usually a good idea to check it to make sure you got your factors right. So x plus 5 and x plus 5 are factors. Now it just happens to turn out in this case, that it's a perfect square. So we could say this equals x plus 5 squared. So x squared plus 10x plus 25 has a perfect square. Call a perfect square because it's x plus 5 times x plus 5. All right, let's try another example. Okay, so let's look at x squared minus x minus 20 this time. And we want to factor it. Okay. So we want to factor this x squared minus x minus 20. Well, we're going to have two factors again, if they exist. One is x. So our first term is x here. That's obvious because x times x equals x squared. So that'll get our first multiplication here. And now, so we looked at this. Now let's look at this. So now we need 20. So for 20, we can have 20 times 1. We can have 2 times 10. We can have 4 times 5. So which are we going to choose to put in here? Because we know that this number times this number needs to equal negative 20. So it could be any of these combinations. But what combination produces a negative 1, essentially a negative x, when we add them together? So if I were to take 20 and either add or subtract 1, I'm going to get 21 or 19. That doesn't look right. So this doesn't look like this could be the factors. 10 and 2, either 12 or 8 if I add or subtract those. So this doesn't look right. 5 and 4, I could result in a 9 or a difference of 1. And this is 1. So this looks very promising. This looks very promising. So let's stick in here 5 and a 4. Now the question is, what do we need for signs? Well, we need a negative 20 here, and the only way 5 and 4 can create a negative 20 is if one is positive and one is negative. But which one? Okay, well, when we add those two together, we need to get a negative x. So the only way that can work is if the bigger number has the negative sign. So I'm thinking it looks like that. Now let's check it. Let's check it. So 4 times negative 5 is negative 20. That's good. X times minus 5 is minus 5x. 4 times x is plus 4x. And we already did everything else. So this equals x squared minus 5 plus 4x equals minus 1x, or minus x minus 20. And there we go. Now notice the factors of this are not a perfect square like the above. They're two different factors. So you can have that possibility. Let's look at another problem. One more. X squared minus 64. Here I don't need the parentheses. Let's get rid of these. So how do I factor this? Well, again, I have an x here and I have an x here. I know that. And then 64. Well, 1 times 64 would work. Maybe 2 times 32 is a possibility. Those are two factors. 8 times 8. Now that looks really promising, because notice we're missing the x term in this relationship. We just have x squared straight minus a constant. So if we stick an 8 times an 8 in here, 8 times 8 is 64. It needs to be negative. So one of these has to be negative. The other has to be positive. Well, let's try this out. So x times x is x squared. X times minus 8 is minus 8x. And then 8 times x is plus 8x. And then 8 times 8 is going to be minus 64. Now look here. We got a minus 8x and a plus 8x. These things cancel. So we're left with what we x squared minus 64. So anytime you see a quadratic equation minus a constant, you could just take the square root of this number, and that's going to be your factor. Now, how about this idea? X squared plus 1 equals x and x, and our only factors of 1 are 1 times 1. So this has to be 1 and this has to be 1. So now the question is, do we make this negative negative or positive positive, because this has to be positive 1? Well, let's try both. If we make it negative negative, what do we get? We get x squared minus 2x plus 1. There's a 2x in there. Okay, so that's not the right way to go. Let's try the positive. We got x squared plus 2x plus 1. Huh. I can't figure this one out. Well, let's think about this. If you think about this further, there really is no two numbers that you can multiply by. So x squared equals minus 1. If I were to look at this equation and set it equal to 0, I guess that would give us some insight. If we looked at x squared plus 1 equals 0, and then we go x squared equals minus 1, then what are we doing? We're saying then that the square root of x equals the square root of minus 1. And there are no real numbers that you can come up with, no two of them that are exactly the same, that equal minus 1. So yeah, this guy, you can't factor with real numbers. So occasionally you get one of these equations that you can't factor. So keep that in mind. And that's about all we have time for here.